Hello everyone, welcome back in another video. I am Vaibhav and today's date is 3rd of September 2022 and our today's video topic is very interesting. Our topic is the difference in between hash code, hash map, linked hash map and tree map. So we are going to see all those different types of maps within a one video. So let's start. Before going towards, let's we see our first point, that is the hash code. So why we need a hash code? So basically hash code is nothing but hash code. It is an integer which is uh, represent the internal address of an object. So when we need that uh, hash code, suppose we are have to performing some arithmetical operations like some addition, subtractions, uh, then reminders or modulus operations are there. So that time, if we are using a map or we are using some nodes, that time we are using a different types of data types within a same nodes or within a same data. So that time we are suppose using an integer, string or float. That time within for the integer and float there is not any problem for that arithmetical operation, but in case of string or character, that time there is a major issue because they are don't have its specific value. That's why we are not able to mod that value or some do any arithmetical operation on that value. That's why we have to convert that value or convert that object into the hash code value. So hash code is basically predefined library or uh, predefined storage within a Java, or it is the stored within a object class. So due to it, we are able to convert any wrapper class into the hash code. Sorry. So int having integer wrapper class, string having string wrapper class, like that we are able to convert that value into the hash code, and we are able to do arithmetical operation, or we have some its specific or different standard value, standard address for that specific object. That's why that each hash code are having different as per their object. That means different objects are having different hash code values or different integers. So when we are using our hash code, so mainly we are using hash code for the performing operations like adding or storing, for the searching, and for the removing the objects from the our code. That time preferably we are using a hash code, or we have to use the hash code for performing that operation. We are performing that cases within our uh, collection. In collection we are using this concept in a set and map collection. Okay, we are using all those hash codes within our set and map collections. After that, next point is that how to create a hash code. For creating a hash code, there is a predefined method within an object class. Object class having predefined method for creating an hash code. We are creating hash code by using a syntax like int hash code, and within that parenthesis we are giving that specific object. After that we are getting output in terms of integers. So that's why after that integer value, that is integer value, it's a reference to that internal memory location of that object. Suppose we are giving the object of string like abc. So when we are writing like as int hash code within parenthesis abc, so it gives a output within an integer, that is like output like 11121. So that is the hash code for that abc. So we are able to do performance operation on that hash code. Okay, that is the hash code. Now we move towards our next point, that is the maps. So before going towards our hash map, let's see what is meant by map. So map is nothing but it is an combination, or it's an similar type of, it's a collection of data with a key and a value. It's a pair of a key and a value. So whenever we have to store some data within the collection of the, by the different collection, we have to create the data within the different types of object at a time. That time we use a map. Suppose we have to create an application for the school attendance. That time we are using roll number as a key, and we are using a student name as a value. So in this scenario, we are giving two different types of data within a one object. That is, one is the integer and another is a string. So we are able to store the data by using a map. So within the map, we are storing all that type data. So one more important point is that map is a not child class of our collection. That means collection is a different part and map is a different part. Sometimes we are say that the collection map is a child class of a collection, so that is actually wrong. So collection is a different part and map is a different part. Okay. So come to the point. When we are using that key and pair combination, that time we are able to store the data within a within their proper key pair combination or key pair collection. That time we are able to store that specific key for the specific value. That means when we calling that key, we get that particular value. So one major point is that we are not able to store duplicate keys, because suppose in a class they are having roll numbers like 101 for Akash, for 102 for Shubham, 103 for Ayush. So that time we are directly confirm that the roll number should be different. That means there is not any repeated or duplicate roll number, but there is a maybe chance to the duplicate names. That means within a class there is a chance of having two students with the same name. So that is not matter. Our whole map should be works on a key. That's why we are not allowing any duplicates within a key or within the map. So that is our map. So we go towards our point, that is the hash map. We are see hash code and we see map. So it is the combination of hash code and hash map, and we called as a it is a combination of hash code and map, and we called as a hash map. Okay. Within our hash map, we are see in our previous video, there is a structure like a array which are having some specific size, and with that array containing a linked list, some linked list. So default size for creating our hash map, we are writing a syntax like a map. Within the subscript operator, within the generic operator, we are giving a data type like a string comma integer. After that, map is equal to new hash map. That is the syntax for creating a hash map. So our all maps are working on a same parameter, that is based on a key value. Okay. So within all those types, key value should be considered as a continuous. Okay. So we see that syntax. After that, the creating that object for the hash map, the structure is like that. When we are getting some values within our hash map, that time the allocation for that specific element should be done by their indexing. That means suppose there is a we are adding something like 10,000 elements within that map. That's why it's actually it's when we are think to create an array for the 10,000, it is easy, but not it's easy as physical. That means we are not creating 10,000 size of 10,000 array physically, because the our heap memory should be get full, or it should be not applicable for a memory allocation, or it's not actually feasible for the developer. That time we are using a concept of hash map. So hash map are having the structure like there is an array structure. Okay, so default size of that array structure is a 16. We know the indexing of array should start from 0. That's why the indexing for that array should be starts from 0 to 15, but it's having a length or size of 16. We are also called that each with each index as a bucket. So there is a size of a 16 size of 15 buckets within 16 buckets within that array, and that each bucket containing a node. In our previous video, we are discussing about nodes which are containing a key and a value, and the next is also there. That means it's containing some different types of key values and key values or next elements. So that is the combination of collection we are discussing about in our previous video. So each bucket containing a node, and that node are extending toward next node. That means there is a combination of nodes. When we are entering data within our hash map, that time that data should be within a different types of data type like a string or integer. So that time we have to convert that key into the hash code, because user can give as data within an integer or within a string. We are don't know. That's why we have to convert all of those data into the hash code. After the converting the data into the hash code, we have to allocate some specific index or some specific location for that individual elements. That's time we performing a operation on that on that hash code. We can convert by using a modulus for finding that index. We can find out that index like where do arithmetical calculation like index is equal to hash code, and we are more that hash code by a length of that our array or number of buckets in that array. So after that calculation, we get the hash code or we get the reminder. That reminder can show us the index of that bucket or index of that particular array. So that reminder directly pointing toward that index. So we can directly put our element within that particular index. Suppose we are calculating for a 10. That time it shows an index of 1. That time we put our value within that first index or within a first bucket. That time that bucket containing a different types of nodes or different array list is there. Different linked list is there. So as per their sequence, we are putting the value within that our list. So that's easy to store thousands of thousands elements of data and thousands numbers. We are easily stored within the hash map with the minimum memory. So main purpose of hash map, it goes easier to store the data, and it's reducing the time of searching or finding that any element within our database. That means we are achieving that operation by using database. We are use a put command for insert the data within a hash map. By using a put, we are giving its key value, and we do all those performing the operation on it. So that is the overall working of a hash map. By hash map, we are able to get the we are able to store the maximum data within minimum memory, and we are able to find out the element or searching operation easily as compared to the other. But major disadvantage is that our hash code does not follow the insertion order. That means we are giving data. Suppose I am giving first key as a 10, second key as a 20, third key as a 30. So that time it's not following their insertion order. When I am retrieving that value from that map, that time it's not giving me that value as per sequence and putting that value within the map. It gives its value as per their calculation, arithmetic calculation, as we see, it gives a value of output in terms of some jumbled manner. So that's why that is the one disadvantage is hash map. But that disadvantage can be covered in our next point, that is the linked hash map. So linked hash map is also combination of linked list and map. That's why we call it as a linked hash map. So all structure of linked hash map, within that the map concept is same as a hash map. Hash map should be works on a hash table, as we see in our previous video, and our linked hash map are also based on a hash map. So same all algorithms or some all the structure of linked hash map is same as hash map, but additional concept is that we are adding a linked list within the hash map. That time whole structure is same as hash map, but the main purpose of adding a linked list, that is our hash map does not follow the insertion order. That's why we are not able to get the proper value or a proper indexing within the hash map, because hash map does not follow the indexing, it works on a key values. Okay, so we overcome that problem within our linked hash map. So linked hash map containing a linked list within a with also hash map. So that time our whole structure is there, and on that whole structure we are implementing a linked list on that map. That time we creating a first bucket or first index called as a root. We are creating that root at outer side of our array. It works different, but it's working vice versa, or it's working with the same time of our mapping. So we are not get identify that things, but it's work differently. Okay, so it can follow the insertion order as per our putting, or as per our giving the input. Suppose we are giving input like a 10, 20, 30, it gives us output into the output same as a 10, 20, 30. That means when we checking same as our previous video, we are discussing about linked list. We check that first root should be null. If that is not null, we are putting the element on that root, or that null root value. Then we are going to check when we putting the next value 20. That time it check that root is root dot next is null or not. If that null, we putting that value. After that we are putting the next value 30. That time also it check that root dot next is empty or not. If it is empty or it is null, that time we putting that 30 value. So that's why within that case we are able to store, or we are able to working on their, we are able to achieve the insertion order. That's why we are that main advantage is that main advantage of linked hash map is that when we are, yeah, when we are using a storing a data, or when we are uh, setting the memory by using a hash map, that time we are easily inserting or removing or do any operation like insertion or deletion, that easier because of using a map. That means we are using map also within that linked hash map. We goes to reduce the time, or goes to increasing the performance, like operations like insertion and deletion is faster as compared to the others. And but one more also thing is that there is a linked list also, that's why we are easily get the follow the insertion order, and we are easily find out the specific element within our map by using a linked map. So all those combinations should be within our linked hash map. That's why it's give us more highly performance as compared to the hash map. Linked hash map giving us high performance as compared to the linked hash map. So linked hash map is a combination of linked list and map. After that, we go to our next point, that is the tree map. Also, we are discussing about tree map. Tree map should give us output. That means our TreeMap also not following the insertion order. TreeMap is a structure like dividing their dividing their specific value in a maximum and minimum manner. It's when we using our TreeMap, it should when we giving the random numbers or random integers to that tree map. Suppose we are giving like a 5, 3, 1, 2. It gives output in a sorted manner. That means it gives output into the 1, 2, 3, 4. And also when we are giving the alphabets to the tree map in jumble manner, suppose we are giving B, C, D, A. That time it gives output in a sorted alphabet like that A, B, C, D. But in case of our user object is there, suppose we are creating an object of student class or we are creating an object for demo class, that time it does not follow that sorting state, that because that specific uh, that specific object we are creating that does not having any specific values. That's why it does not identify the sorting order for that particular object. We have to implement our by ourselves for that tree map, for the sorting implementation by ourselves. So our tree map does not allow any duplicates. Before version 1.8, we are able to insert the duplicate within that hash map. That time it shows an exception. But in currently version, when we are entering any duplicate within our tree map, it directly overrides that previous value and it gets new value on that particular value. So our tree map can also follow the doubly tree map. Doubly tree map means we are able to travel in forward direction and we are able to travel in reverse direction. That means we are able to go forward and go backward by using a doubly linked list. That is a doubly linked list. Doubly tree. After that, we see the working about tree map. So tree map, when we are giving the value, that value should be converted, sorted, set in a sorted manner. Suppose we are get first value as a root. We are giving a root value as a 10. After that, we are putting next value, that is the 5. So that time our tree map can compare that value with that root value. That value is less than root value or greater than root value. It should be compared. So that time, suppose that we are putting the next value is 5. So 5 is less than 10. So that 5 value goes at the left leg of our root value. So after that we are putting our next value, that is the third. Before that we check that left is null or not. If that left is null, it put that value directly on the left side. After that we are putting a value as a 15. So 15 is greater as compared to our root value. Our root value is 10. 15 is greater as compared to the root value. After that, that value should goes at the right side. Before going to the right side, it check that element at root right, that is the empty or not. If it is empty, then put that directly value on that root. If that is not empty, it is go to check that particular value. Suppose we are again putting the value of 20. That time that 20 value is also greater with that root value. Root value is 10. So it goes to the right side. Before that putting that value, we check that right is empty or not. So there is a 15 value is already present within that particular man. That time we are going to check that value with our new value. So our previous value is 15 and new value is 20. We are going to check that value is greater than or smaller than our next value. So value is 15 and our next value is 20. That's why that 20 is greater than 15. That's why that 20 goes at the right side or right leg of our 15. So whole cycle should be work like in that manner. After that overall operation, after that overall insertion, if we see at extreme right of our tree, that time we get the minimum value at that last point. And if we see at the extreme left of our if we see at extreme left of our tree, we get the minimum value, and if we see at extreme right of our tree, we get the maximum values. That means when we retrieve the value from our tree, that time it gives output in terms in a sorted manner. That means we giving that input in jumbled manner. It's set that value as per the require as per their combination, and it gives output in terms of sorted manner. So main advantage or main difference for the tree map is that when we are implementing or when we are using a tree map, that time tree map should reduce the iteration. Suppose finding iteration in terms of searching, there is the tree of 1,000 numbers. That time we have to identify number of, suppose we are finding for a number 800. So that time in our other maps we have to travel all that 10,000 number for the finding that 800. Suppose we finding 801, we have to travel toward 10,000 number for finding that value, that is 801. But in case of tree map, that should be in minimum cases, because we are comparing that particular value with our root value. That is, if that value is greater than root value, we are directly searching in a right side. So that's why suppose that value storage of 10,000, it should be directly deducting by 50%. Then we are finding in remaining 5,000 only. After that, there is a next value. We are going to check that element is greater or smaller than next value. That time, if we are get that value is less than our next value, that time that we are going to find out that value within the half of their whole 5,000. That means now we are going to find out that value within only 2050 value, between 2015 value. That means we are reducing the 1/4 within only 2 iteration. That means the time of searching or time of finding should be minimum in tree map. After that, by reducing by 50%, by reducing 50%, we get that exact value by minimum iteration by as compared to the other maps. That is the major advantage of our tree map. Uh, we can allow only one null value in tree map at the end, because we are using a nodes. That time we are using combination of key and pair, so we are able to go toward the next element. That time we are able to use the next as a null, so we are able to use only one null, but we are not able to use key as a null on all those maps. So that is the overall discussion of difference in between HashCode, HashMap, linked HashMap, and TreeMap. Thank you.